Hello, everyone. Welcome to Chemistry Review. I want to get you ready for AP Chemistry. And to do that, I'm going to review what we learned a couple of years ago or last year in general chemistry. And I'll be going kind of quickly, but I'll try to put everything into context for you so that you can see how everything fits together. Now, you've had a year of chemistry and you've gone through the whole process. I want to see how everything we do fits together. If you're tempted to listen to this on double speed, I would encourage you to listen to it on normal speed or maybe even half speed because I'm going to go quickly so that you don't have to. All right, so let's start right now. I'm just going to go to the whiteboard and I'm going to work my way through from the very beginning, kind of the way I reviewed before each test. I went back and reviewed what we had learned so far. I'll put a little more detail in this time. Okay, so let's start out with just the definition of chemistry. You know it's the study of matter and the changes it undergoes. All right, so let's go back and look at matter. I know we talked about this. You learned about it in 5th grade. But what is matter? It's stuff. It's just stuff. So chemistry is the study of everything around you. Look around you. Chemistry is involved with everything that you can see and touch. Okay, technically matter has mass and takes up space, or it has mass and volume, but chemistry is universal. It's a very fundamental science, and it all relies on this smallest building block. It relies on the atom. And so making the connection between the atom and how it behaves, how different types of atoms connect to one another and the properties that result is key. So we'll look at the structure of the atom. I'll remind you of that. And we'll look at periodic trends. We'll look at how atoms differ from one another in a predictable way. And then we will look at how atoms bond together. Underneath all of this is the electromagnetic force. And I don't think I really appreciated this until I was a mature chemist, so I'm telling you now to save you some time. This is the interaction between positive and negative, between charges. Opposite charges attract, like charges repel. This shows up everywhere in chemistry, starting with the atom and the attraction of the electrons to the nucleus, but then moving on to assemblies of atoms, molecules, and different parts of the molecule are going to be slightly positive or slightly negative, or not, depending on how the atoms are arranged. And that will affect how those molecules stick to each other, and that affects the properties like what sticks to what and what will wet out and what will bead up. Like why does water bead up on a wax surface and spread out on clean glass? All of that goes through this positive and negative effect and then eventually back to the atom. Okay, so let's look at matter first before we get to the atom. We have some sample of matter. Anything you see around you, and matter can exist as multiple substances or as a single individual substance. If there are multiple substances and those different substances have different physical properties, and we can separate a mixture based on those differences in physical properties. So for example, if the physical property is boiling point, if water has a different boiling point from alcohol, then we can separate water from alcohol by boiling the lower boiling material out and condensing it, and what's left behind is the higher boiling material. That's called distillation. If one thing is a liquid and one's a solid, then we can filter to separate the two substances. There are just all kinds of clever ways that chemists have used to separate substances based on physical methods. Okay, so we have mixtures and we have substances. Mixtures come in two types. There are ones that are completely uniform throughout, and those are called homogeneous, meaning same type. Homo means same. And if they are non-uniform, we say there are multiple phases. Each phase has a constant composition, but there are different phases with different compositions in contact with one another, and that's called heterogeneous. Hetero meaning different. And for this, you can think of oil and water, and maybe for this, you could think of salt water. And we call these homogeneous mixtures solutions. Okay? A substance is made up of little tiny particles, ultimately atoms, but the atoms can all be the same type. And so if all atoms are the same type, and that is called an element, and there's only around 100 of them, and they're listed on the periodic table of the elements. And if there are different types of atoms, then we call that a compound. Now, one thing about compounds that makes them different from just mixtures is that these have a definite and constant composition. That's an important distinction. A mixture can have a variable composition. In other words, if you have salt water, that's a solution, you can have 10% salt and 90% water, and we would call that salt water. You could have 5% salt and 95%. It's still called salt water. So a mixture, homogeneous or heterogeneous, it doesn't matter, does not have a definite specific concentration or composition. A compound is very specific. It's a very specific ratio of the different types of atoms. For example, sodium chloride, NaCl, table salt. For every sodium atom, there is exactly one chlorine atom. And for water, for every oxygen atom, there are exactly 2 hydrogen atoms, and they're connected together. There's a different compound called hydrogen peroxide, and for every oxygen atom, there's exactly 1 hydrogen atom, and so it has a different chemical formula. This is important. We're going to focus our attention on atoms, okay? But this is how it all fits together. And then we'll put the atoms back together to make compounds, and then we'll take mixtures of compounds and understand how they work. But this is where it all starts, fundamentally right here, okay? And we'll end this first video here.